All right, for the statistics notes, I wanted to do something a little bit different. I had multiple versions of these notes, and the ones that we went through in class were a little bit more detailed, so you can always go back through there. But I wanted to just highlight what is the most important thing for you to know with statistics for us moving forward. And this version I have is much better than that and probably what I should have done to begin with. So here we go. First, statistics. Why are we doing them? Well, they help us to better understand the meaning of a sample data set. So what do these numbers actually mean? We have body temperature data, and you just have a bunch of it right here. And it doesn't mean a whole heck of a lot just having raw data. So what we want is to be able to analyze it. When we analyze it, we're able to arrive at conclusions about our data. We can make claims about our data. We can support arguments using our data. We can estimate the reliability of our data, and we can effectively communicate conclusions about our work to a larger scientific community. So rather than just give them a giant data set that looks like this, we can find values that make more sense. And what we use are these descriptive statistics. We use a mean, which is an average, sample size, how many values were there, standard deviation, and standard error. So we're going to dive into each one real quick. The mean, or the average, again has this equation that's going to be on your equation sheet. But really, we're just adding all the values and dividing by however many there were. So if we wanted to calculate the sample means of two environments, wet and dry, we could take the values. So if there were, let's say, we were looking at temperature data, and let's say one was in Celsius, one was 32. It's a nice warm area, and one time it was 30, and the other one was 31. We'd probably have a lot more data than that, but for simplicity's sake, we just add the three of them together, and we divide by 3, and then we hit equals on our calculator, and we would get 31. Okay? Standard deviation is determine the amount by which our values typically differ from the mean. So again, what you're going to notice with this, and again you have the equation here, and we'll go through what this means all in 1 second. But if you have a low standard deviation, everything is going to be right around the mean. So you're going to have a very nice high bell curve. If you have a high standard deviation, that's going to be nice and low like this. And we talked about how one standard deviation from the mean is what 2/3 of the people fall between. So roughly there and there. I can't draw straight lines. But this whole area in here is within one standard deviation. And then if we go out to this part 2 times, then that is 95% of people would fall within that. Okay? And again, you can see this in data points. If you have a data point that is scattered like this is a high standard deviation. Values are all over the place. Versus if they're all grouped together kind of along this best fit line, that's very low standard deviation. It shows a very obvious trend through there. So, given our values, let's calculate our standard deviation. So our values were, I'm going to switch over to text here, but our values were 32, 31, and 30. Okay? So to calculate standard deviation in that equation, it says for 1 for us to find the mean, which we already did. So we know the mean is 31. Okay? So now, to calculate this, or to actually do it, we are going to, I'm going to switch over to have the right color here, okay? We have to take each value and find the difference between it and the mean. So this is the top part of that equation, that is x minus x bar. Okay, x bar is the mean, so that's the value 31. X is each of these. So what we have to do is do 32 minus 31 equals 1. And then 31 minus 31 equals 0. And 30 minus 31, each value minus the mean, and in this case it's -1. Now the next step, if we go back and look at this equation, is to take the x minus x bar, which we just did, square it, and then add all the values together. So I need to square this, and square this. So we have 1, 0, and 1. Now we need to do the sum. So 1 plus 0 plus 1 is 2. And standard deviation tells us that standard deviation is equal to the square root of the sum of x minus x bar squared over n minus 1. And n is our sample size. So we had 3 values, so our n value is 3. So this is equal to the square root of 2, because that was our sum that we got here, over 3 minus 1. So 2 divided by 2 is 1 in the square root. So our standard deviation is 1. So what that means is our mean value, and what we can write is our mean was 31, and our standard deviation plus or minus 1 means that on average our values were 1 degree warmer or 1 degree cooler than the average. All the values were falling within there. Okay. Standard error then is used to determine the precision of the mean value. Now what that really means is how confident you are in your mean value. So we talked a little bit about this in class, but the higher this number gets means the lower this number gets, which basically means that you're more confident in your mean value. So as we look at this, how close is the calculated mean to the true mean of the population? We talked about error bars, and you can see on here in the graphic that this one with the giant error bar means we can't trust you. If the bigger these things get, the more uncertain this value is. So to determine the confidence in the data, we always want to do what is called the 95% confidence interval, which is plus or minus 2 standard errors of the mean. Okay? So what that means is we have to solve for standard error of the mean. So standard error of the mean is standard deviation divided by the square root of the number of values. So for us, our standard error is equal to our standard deviation over the square root of n. Our standard deviation was 1 over the square root of 3. So we can pull up a calculator, and in our calculator we can figure out what that is. So the square root of 3 is 1.73. So 1 divided by 1.73 is 0.578. 578. And that's our standard error. But if we want 95% confidence, or in other words, that we're relatively certain that most values will fall within 95%, or 95% of values will fall within 2 standard errors of the mean, we have to multiply that by 2. And that is 1.16. And that value then is what we are going to use for the error bars, 2 times the standard error of the mean. So we talked about this. Data is statistically significant for when error bars do not overlap. So in this case, you see that, again, 2 standard errors of the mean, these error bars are not overlapping. So there is a significant statistical difference between whatever Shady and Sunny was with our comparison of ivy leaf width. If they do overlap, then it's not statistically significant. So you can see that even though this has really little error bars and this has really big ones, they overlap. So there is no statistical difference between these. Okay? And we just did this, we calculated. And when we report, we are always looking for the 95% confidence intervals. So all of them will be 2 standard errors of the mean. So you can see that's what all of these values do. And this is actually a graphic question. So that's it for statistics. If you have more questions, make sure you're either coming to XBlock or you're asking me for help when you get a chance.